Hi and Assalamualaikum, my name is Akila binti Rahman, and this time I want to show the simulation of steady state behavior of RLC series circuit. In this analysis of the series RLC circuit is the same as that we do for experiment 4, but this time we just add on the reactive power as the output in the table and also in the simulation. This time we use the 100 ohm, 50 millihenry and 16 microfarad. We change for 10 volt amplitude to the VAR, the reactive power. We can see the output, and we change also for the watt. Okay, we run again and we wait for the output, and that's the output. Next, we change the amplitude to 20 volt. To 140 volt is just a display for the power source, but we play the range of the amplitude. We change it from 10 to 100 volt as per request as the table and in the output. And then we change the amplitude to 30 volt, and we run again and wait the output, and that's the output of the reactive power. Start the simulation and change to watt. Okay, this is the watt reading. Next, we change to 40 volt of the amplitude power of the amplitude source, voltage source, and we run again. We see the watt output, and we also change for the VAR. In every session of the range changing of the amplitude, we must play around with the VAR and the reactive power, because that is the demand for. And then we change it to the 50 volt. Change the amplitude and we see the VAR reactive power reading. Next, we change again to the watt and run the simulation again, and wait a minute. Okay, that's the output, and we change to 100 volt. We test for the maximum, and that's the reading of the watt. Don't forget the VAR. And okay, that's it, the VAR reading. Thank you. Next, we go to the simulation number 2, which is in this range. We change the resistor to 50 ohm, which is before is 100 ohm resistor, and then other is remain the same. Okay, that is the reading for the watt of 10 volt amplitude. Next, we change the amplitude to next level, 20 volt, and we run again and see the power reading in watt, and change to the VAR. Don't forget the VAR, just repeating the same. Okay, that's the reading of the output of the VAR of 20 volt amplitude. Next, the 30 volt amplitude. Just play around with the amplitude as the range changing and other remain the same. Take for the watt and wait for the reading, and that's the output reading. Next, we stop it and change to the 40 volt amplitude. and run again. Okay, that is the output reading of the watt power. And don't forget the VAR. Please don't forget the VAR, the reactive power. And we run again to see the output. Okay, that is the output. Next, we go for the maximum volt of amplitude. Bear in mind that this is only the example of our simulation. We run again for the watt power, and that is the output reading of the watt. Thank you.
Hello and Assalamualaikum. My name is Shafiq and now I will continue the presentation on Activity 2. Activity 2 is about the experiment on steady-state behavior of RLC parallel circuit. For this circuit, we need to connect 50 ohm of resistor, 100 millihenry of inductor, and 28 microfarad of capacitor parallel to each other. Our voltage source will become our variable in range 10 to 100 volts. From this circuit, we are going to find the current of the circuit, the current of the inductor, resistor and capacitor, and also we need to find the power and the reactive power. Now, I will start our simulation with the voltage of 10 volts. So here is the result of our current, our power. This is a reactive power. This one is current for resistor, current for inductor, and the current for capacitor. And now we are going to use 20 volts. Volts. So as well as you can see, when the voltage supply is increased, the currents of this circuit will also increase. Volts. So we can conclude that the voltage is directly proportional with the current. Volts. Also, we can also conclude that when the voltage is increased, the power and the reactive power also increase. Now we are going to use 60 volts. Now I will show you the result of the current of the circuits until 100 volts. $70 volts. This one is 80 volts. $90 volts. And finally 100 volts. So this one is the final result. So that's all from me. Thank you.